Hello, and today we have this problem from subscriber. It's not very difficult, but I'm low on time, that's for one. For two, it's not completely terrible in terms of difficulty. It's gonna last a while, and I think it's gonna be interesting anyway, regardless of the difficulty. So the equation, this is cubic has non-negative roots p, q, and r, and we have s defined as the sum of square roots of those. We need to find the value, the absolute value of this quartic. Okay, so first of all, the first intuition is that we need to find how p, q, and r relate to coefficients of this cubic. So let's write it down. X minus p times x minus q times x minus r. And let's open the brackets. We get this x cubed minus px squared minus qx squared minus rx squared plus pqx plus prx plus qrx plus pqr equals, okay, no, this is what we get, and from this we can infer some facts about p, q, and r. First of all, since we have minus 9 here, we have minus p, minus q, and minus r. We can say that p plus q plus r gonna result in number 9. Alright, cool. Now another fact we have is pq plus pr plus qr gonna result in 11, and p times q times r is gonna result in a negative 1. Oh wait, no, there's a negative sign here, so gonna result in 1. Okay, cool. Now with this information in hand, we need to deduce the value of this expression, and what I'm gonna do is I'm gonna look through this and find some relations. First of all, what we have here is s to the 4th power minus 18 times s squared minus 8s. And what I'm going to do is I'm going to look what happens to s when I square it. So s squared. Now, using the formula for squaring three parts of a sum, we get p plus q plus r plus 2 times the sum of roots of pq, root of pr, root of qr. Okay, cool. Now with this in one hand, we can already simplify it, actually. P plus q plus r, as we know, is 9. So I'm just going to write down 9 here. Another thing you can notice is that you can try pulling out the square of some formula, and conveniently we have a 9 here. 2 times 9 times s squared. So when we do try to do that, we get s squared minus 9. Oh, that is going to be squared. Now since we had 89, we need to subtract it, so minus 8s minus 89. What is 89? 81, and that's going to be the same as this expression over here. Call it big R, the result. So now since we have 9 here, it can just become this thing here. So 4 times the square of the sum of a bunch of roots here, PR, QR, and all of this here is squared, and is 8s minus 81. Now with this we can apply the same exact formula. First we find the squares of these things and sum them, and we have a nice formula here that lines up with it. Not a formula, an equation. This pq plus pr plus qr is 11. So what we can say here is that after squaring we get 11 plus 2 times, now we just find the products of these things. So what we get is p times root of qr plus p times root of no wait, q times root of pr plus r root of pq minus 8s and 81 again. And now what I'm gonna do is first I'm gonna bring out the 4 times 11 here. I want to deal with it. So 44 minus 81 here plus 8, and here we get p times qr plus q times pr plus r times pq, and we get the minus s part here. So minus p minus root of p minus root of q minus root of r. And now what we can do is we can try and bring out some things here. So what I'm looking at is you can bring out the root of pqr here, pqr, get a sum of these roots. So p plus q plus r minus the same sum root of p plus root of q plus root of r. Now let's simplify this here. That's gonna be minus 37, I think. Okay, it's 8. Now root of pqr, recall how pqr is just 1. So what we get here is, well, it seems 0 cents, and then we get just the sum of roots, and then we subtract them back. So yeah, the answer is going to be negative 37. Now they ask for the absolute value of the answer, so the answer is 37. All right, that's it. It was pretty quick. Bye bye.